So let's look at grouped frequency distributions for continuous data. So this is a little bit different way of grouping the data, and you could actually use this for continuous or discrete data, but it's very helpful for continuous data because in continuous data you can measure as accurately as you want. So these can have as many decimal places as someone measures to, and whatever they measure to, this method will work. You will have each value belonging in one and only one class. So as far as the homework is concerned, you're going to be given, this says construct a group frequency distribution starting at 1.5 with a class width of 6. Now, of course, in real life, you're not given these numbers, but on the homework, they do give you these two numbers. And from that, you should be able to get a particular distribution. So that's how we're going to do it. So we're going to start at 1.5, and we're going to have a class width of 6. So the intervals have a size of 6. And so here's how to do this. Oh, you know what? I never said what this data was at the beginning. So this is actually number of miles commuted. Like workers commuting to work. Okay, so I forgot to write that down. This is the number of miles commuted, which is a continuous variable. So technically they could measure, 8.5 or 8.7, 8.75. However they want to do it, they can measure to however many decimal places. Okay, but we're going to be able to graph it using a group frequency distribution. So I'm going to have number of miles and frequency. Okay, and then it says here start at 1.5. Okay, so this is actually, it's not going to be a class limit. In the last video, these were class limits, but now this is a class boundary. So let me explain what I mean. It's going to be 1.5, okay, and I'm going to add 6 to that, and if I do, I get 7.5. So this class is going to be from 1.5 all the way up to, but not including 7.5. Okay, so these numbers then will belong in one and only one of these classes. Okay, but if you belong, if the number is on the boundary, like if I had a 7.5 up here, that would be on the boundary, so it would be in the next class up, which is going to start at the same number, 7.5. And then I add 6 and I get 13.5. Okay, so these are the same, but the values only belong to one class because anything on the boundary is in the next class up. Just like I would take 7.5 and round up to 8, anything on that boundary is in my next class up. Anything below it, like 7.4999, would be in this class, but once you hit 0.5, you're in the next class up. So this way, every value, no matter how many decimal places you're measuring to, will belong to one and only one class. So now this is 13.5, and then add 6, I get 19.5. This is 19.5, I add 6, and I get 25.5. And I can stop here because it looks like the maximum value here is 20, and that'll belong in the last class. So in this example, I have only 4 classes. That's okay, but it's probably more desirable to have maybe 7, 8 classes. So they say somewhere about 7 to 10 classes is ideal. When you start getting below 7, that's not as good. If you get above 12 or something, or I should say if you start getting below 5, that's not good. Above 12 is not that great. 4, it's right there at the borderline. But if you wanted to have more classes, what you could do is just shrink your class width down to 4 or something like that, and then that would create more classes. Okay, but we're going to use what they told us here, and now I need the frequency. So it's actually kind of hard to get all the values here that lie in each class because they're so random and it's easy to miss them. So what I do is over here I'm going to put little hash marks. So 11 would go here, 11 here, 8 is here, 20 is actually here, 6 is up here, 5 is up here, and 9 is right here, and 11 right here. And then 15 is right here, 4 is right here, 3 right there, 13 is going to be right here, 10 is right here, 8 right here again, 2 up here, 16 looks like that's right here, and 12 is in this one, so another one there, 7 up here. Okay, so now you can see I have 6 observations in this class, and I could kind of draw a little line here if I wanted to, so it's not so confusing. I got 6 observations, 9 observations, 2 and 1. So again, I want to make sure I haven't missed any here, so what I can do is add these up. So 15 plus 3 is 18, and I have 18 values here. I got 3 rows of 6. So this checks here, so we're good. And now what I can do is draw my histogram here. And what I'm going to do is I'm going to put the boundaries along the bottom. Okay, so I'll do like 1.5, 7.5, 13.5, 19.5, 25.5. Okay, so I just put each of the boundaries. I don't repeat it here. I just write them on the axis like a number line. And then from 13.5 all the way up to, but not including 7.5, I have 6. And actually I need to put my frequencies here. They go up to 9, so I think I'm going to do 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. So this one will go up to 6, all the way up to, but not including the 7.5 here. So that would be that. This one goes up to 9. And this one goes up to 2. And then this one goes up to 1. And then you could shade these in. And so that's how you do it. So you got these class boundaries instead of class limits. And with continuous data, no matter how many decimal places you have, it'll belong to one and only one class. So now we got to make sure I put a title on there. So this would be number of miles for, I'll say 18 commuters. How's that? Okay, and then this here would be number of miles. And of course this here would be number of commuters. Okay, and then there you got a data set, or you got a histogram of the data set. And so if you were interested in the shape, I would say this is probably slightly right skewed. Most of the data is here, and then you don't really have a single outlier skewing the data way over here, but in general it's probably a little bit right skewed. Not terribly right skewed, but maybe a little bit.